Think about the last time you filed an insurance claim. Maybe it was a fender bender, a doctor's visit, or a damaged roof. You submitted some paperwork, waited a while, and eventually got a response. During that wait, your claim moved through multiple steps. It was reviewed, validated, priced, approved or denied, and finally paid out. Each step felt simple from your perspective. But in the back end, something interesting was happening. All those steps might have been handled by one large, interconnected system. Or they might have been handled by separate, independent systems talking to each other. These two architectural choices are monolith or microservices. And the decision shapes speed, reliability, and how teams work. And most policyholders never notice. Let's imagine you work for a health insurance company. Every day, thousands of claims arrive. Each claim follows the same path. The system checks if the patient has an active policy. It calculates pricing, verifies deductibles, determines what to pay, and sends notifications. Now imagine your company decides to start covering mental health teletherapy sessions. This new feature has different pricing rules, coverage limits, and verification steps. Adding it requires updating multiple parts of the system and coordinating changes so everything continues working smoothly. This example shows how a single business process, which feels simple to the user, relies on careful design behind the scenes. Whether the system is one large application or split into multiple services, the architecture determines how easily new features can be added, how failures are managed, and how teams collaborate. In a monolithic system, all functions share the same code base and resources. The policy logic checks coverage, pricing calculates charges, deductibles tracks payments, and notifications send results. All these functions run together inside the same system. If one module has a bug, it can affect the others. Adding new features requires touching multiple parts of the application and testing the entire system before deployment. Scaling is rigid. If one part is overwhelmed, the whole system may slow down. With microservices, each function becomes an independent service. Policy, pricing, deductible, payment and notifications, each live in their own code base. Teams can work independently and deploy updates without affecting other services. Failures in one service usually don't break the rest of the system. For developers, microservices provide autonomy, flexibility, and the ability to scale parts of the system independently. However, microservices also require coordination. Teams need to align on interfaces, agree on data formats, and maintain compatibility between services to keep everything running smoothly. This is a normal part of working with distributed systems and does not mean the system is failing, it just requires discipline and clear communication. The principle is modularity. Monoliths are single, unified systems. Microservices are composed of independent modules. This choice appears across industries: insurance, banking, healthcare, logistics. Monoliths are often easier for smaller systems. All the logic lives in one codebase, so a single team can understand and manage it. There's no need to coordinate between multiple services, set up complex networking, or maintain multiple databases. Deploying updates is straightforward, and debugging is simpler because there are fewer moving parts. For a startup or a small application, this simplicity can save time and reduce risk. Microservices shine as systems grow. They allow teams to work independently, scale specific parts of the system, and deploy updates without halting the entire application. Failures can be contained, and new features can be rolled out incrementally. Success depends on clear boundaries, disciplined development, and infrastructure to support distributed services. Poorly implemented microservices can increase complexity rather than reduce it. Because there is an underlooked danger when developing microservices. It's possible to unintentionally create a distributed monolith, where services are technically separate but still tightly connected. This often happens when one service can't function without immediately relying on another, or when teams must coordinate every change very closely. Well-defined dependency management, clear APIs, and careful versioning are required to keep services independent and prevent them from acting like a single, tightly coupled system. To avoid this, teams should define clear service boundaries, limit inter-service dependencies, and maintain independent databases wherever possible. Coordinating updates through well-defined APIs, versioning changes carefully, and automated testing ensures microservices retain flexibility and the system scales gracefully without recreating monolithic complexity. Architecture affects everyday experiences, guiding how digital systems behave and respond smoothly. Well-designed microservices allow new features to roll out quickly and isolate failures. Monoliths can slow development but provide simplicity and shared understanding. For users, these choices translate into reliability, claims process correctly, payments go through, and apps stay responsive. For teams, architecture shapes collaboration, how safely changes can be made, and how systems can grow. Even in microservices, adding a feature often requires well-defined dependency management. Services may rely on each other for data or functionality, so teams must align on interfaces, data formats, and deployment timing. Poor coordination can cause delays or errors, even if the services are technically independent. Whether it's a monolith or microservices, the decision affects speed, reliability, and resilience. Thoughtful architecture quietly ensures scaling to meet millions of user requests without chaos. Next time you submit a claim or use a complex app, maybe you imagine the invisible path your request travels. Is one large system handling everything, or are multiple independent services managing each step? Either way, it works because of careful design choices. Some systems are steady and unified, others flexible and distributed. Both can succeed, both can fail. Even when we don't see it, hidden complexity enables the technology we rely on daily. Whether a system is monolithic, microservices-based, or accidentally somewhere in between. That quiet orchestration allows apps to scale, adapt, and recover from failures. All while making complex processes feel simple. Microservices let systems grow, evolve, and recover without breaking everything. But without clear boundaries and careful coordination, they can quietly turn into a distributed monolith, carrying all the complexity of a monolith with none of the simplicity.